Hello everyone, welcome to NMIT course. I am Praveen Kumar, working as an assistant professor of mathematics. In this lecture, we are going to be discuss about Newton backward interpolation formula. In the previous sessions, we have discussed about locating of the point. In the lecture number 2, we discussed about how we are going to be constructing the table based on the locating the point. If the point is located end of the table, so we are going to be use the backward differences table. So based on the backward differences, we are going to be use the Newton backward interpolation formula to evaluate the unknown value from the known points. Let us see what formula we are going to be used to evaluate if the point is located end of the table. So yp is equal to yn p del yn plus p into p plus 1 by 2 factorial del square yn plus p into p plus 1 p plus 2 by 3 factorial del cube y and so on. So, this is a formula where we are going to be used to evaluate the value if the value is located end of the table. So, to find the p value, so the p formula is x minus xn by h, where x is for what unknown value we are finding, that unknown value is called x, where xn is the last value, the x series, where h is so step size difference between the two successive values of x. So, using of this we can find the p value, substitute back in this. So, to get these values, just we must be construct the backward differences table that we discussed in the last sessions. Look at the question how we are going to be find. So, the backward differences notation is, we can call it as del or nabla. This we discussed in the session number 2. Just go back and check about that notation. So, use Newton backward interpolation formula and the given table of values, obtain the value of f of x when x is equal to 1.8. Look at this, 1.8 is located around end of the table. So, if the point is located around end of the table, to evaluate the value or to interpolate the value, we use Newton's backward interpolation formula. So, around exactly around end of the table, that is what to interpolating the value, we are going to be use this particular Newton's backward interpolation formula. And even this Newton backward also having the two kind of the areas we are going to be use. One is finding the unknown value, the other one is finding the interpolating polynomial. But where we are finding the value located end of the table, to evaluate that I am using Newton backward interpolation formula. So, for that we are going to be construct the backward difference table. So, these are the x and y are the given values. Using of these given values, we are going to be construct the backward difference table. So, as we know, the backward difference operator is del, or you can call it as nabla. This is called del square, this is called del cube, this is called del power 4. So, because as I said in the previous session, 1, 2, 3, 4, 5 values, n is equal to 5, obviously the table will consist of n minus 1th order. So, 5 minus 1, 4th order table we are going to be get. So, as we know what way, just we are giving the forward, here also we are going to be give the same kind of the notations, y0, y1, y2, y3, y4. So, difference of these two, so y1 minus y0, so the difference is 0.48. So, here the notation is del the last value, whereas the forward we consider this, if it is a backward we will take the second value. So, nabla y1, difference of these two, nabla y2, difference of these two, nabla y3, difference of these two, nabla y4. Like this we find the difference. So this is called the first order differences. If we find the difference of the first order differences, will we get the values? That values are called second order differences. Difference of these, just we are going to be get nabla square y2. So difference of these two, nabla square y3. Difference of these two, nabla square y4. So difference of these two again same, nabla square y3. Difference of these two, nabla square y4. Difference of these three, so nabla cube y3, nabla cube y4, nabla power 4 y4. So these differences we are going to be substitute in the formula. If you see the previous formula, so del yn is the last value. So where if you have the y3 or y4, so therefore the formula is slightly, we can write it as y4. So therefore y4 plus p nabla y4 plus p into p plus 1 by 2 factorial nabla square y4. So p into p plus 1 p plus 2 by 3 factorial nabla cube y4. If you see the delta nabla cube y values, nabla power 4 y values all 0. So therefore no need to be even, just need to be substitute, because this value is 0, obviously we are going to be get 0. So only up to second order values we are going to be substitute. So y4 2.61, where we need to be find p value. As I said, p value is x minus xn by h, where x value. So what value we are finding? 1.8. This is what our x. So you can substitute 1.8 minus xn is the last value of x. This is called 1.9 divided by h. H is difference between these. So difference is 1.3 minus 1.1. So which will be called 0.2 is the difference. 0.2. So just you can simplify this. Obviously we are going to be get. So minus 1.8, 1.9. So therefore minus 0.1 divided by 0.2. So obviously 1 by 2, it is negative minus 0.5 we are going to be get. That we are going to be substituting this. Minus 0.5 is the p value. Well, delta del y4 is 0.72 plus p is minus 0.5 minus 0.5 plus 1 by 2 factorial. Second order differences, it is there in the table, use that value 0.08. So just you can simplify, we are going to be get y of 1.8 value we are going to be get. So which is located here. Obviously how we are going to be cross check the answer? If you just substitute x is equal to 1.7, we are going to be get 1.89. If you substitute x is equal to 1.9, you are going to get the value is 2.61. Obviously the result also should be lies in this. So if you simplify, you are going to get the answer is something 2.21 some value we are going to be get. So that is the way, just we are going to be evaluate the value. If the value is located end of the table, you construct the differences table, then we are going to be calculate that value. Even the same way we can also evaluate the polynomials. Using of the polynomial, we can estimate the value if it is even outside the table. So in this lecture we discussed about the Newton backward interpolation formula. So the next lecture we are going to be discuss about the central differences. So as of now I said the three kind of the differences we have: forward differences, and the second one backward differences, and the third one is central differences. So this we discussed in the lecture number 3. So backward differences, this we discussed in the lecture number 4. So the next lecture we are going to be discuss about this central differences. Thank you so much.